To finish off Chapter 2, we're going to look at 4 additional types of graphs. They are called a Pareto chart, a time series graph, a pie graph, and a stem and leaf plot. They're just like our histogram, our frequency polygon, and our ogive. They have certain characteristics that set them apart from the other 3. Starting with our Pareto chart. A Pareto chart is a bar graph. You can see bars here. Those bars are arranged in descending frequency orders, from highest to lowest. So our categories, our Pareto chart is used for categories. Our categories are arranged in order from smallest or from largest to smallest and set there on the x-axis and then graphs. So our Pareto chart, if we made a mock x and y-axis here, would be categories down here along the x-axis, and our bars would show those frequencies, and they would be arranged in order from smallest or from highest to smallest. So our graph would always go down from left to right for our Pareto chart. Time series graph, as just the name implies, it's a graph over a period of time. That time could be minutes, it could be hours, could be days, could be weeks, could be months, could be years, whatever time would be there, but that time would be along the x-axis. So time is on our independent axis or our x-axis, and then just like the rest of our graphs, our frequencies are aligned on our y-axis and graphed. It is a line graph, so we'll plot those points and connect those as a line. Pie graph is the one you've probably seen before. Our pie graph takes that circle and divides it into those different sections or wedges. This one requires the most setup work because we have to have percentages to put into our categories, and we have to convert those percentages over to degree measures so we can use a protractor to measure those angles out and put those on accurately onto our pie graph. And a stem and leaf plot, I think you've seen in Algebra 2. A stem and leaf plot takes a group of numbers and divides those into different classes based on characteristics of the numbers. So if we have 2-digit numbers, the first digit might be the stem and the second digit the leaf. Or if we have 3-digit numbers, the first 2 digits might be the stem and the last one the leaf, just depending on how those numbers could be broken up based on the numerical values. And we'll see an illustration of each one of these here as we go. We'll start here with our Pareto chart. It says construct a Pareto chart from the table showing the average amount of money spent by a family of 4 back in 1996. I'll make my X and Y axis here, and I say make, I'm going to sketch. So along our X axis are our categories in descending order. So if you look up above, housing has a large number of frequencies, 650, followed by groceries, followed by the car, and followed by clothes. So there's the first characteristic of our Pareto chart. Our categories are arranged in descending frequency order, 1, 2, 3, and 4. Over here on the y-axis, we have some choices as far as graphing this are concerned, or putting our frequencies on here. I'm going to go from 0 up to basically 700 or 650, so I'm going to go by 50s. Might not be able to fit this on, but we'll hopefully come close. Not sure I left myself enough room here. Not even close. So I'm going to extend this up a little bit. 550, 600, 650, and 700. So now we'll graph our information here. So you notice our housing had $650. Our groceries had $480. Our car had $350. And our clothing was $250. So that's a quick sketch of a Pareto chart. Now just to illustrate a little difference here, if I were to put the y-axis over here, notice we don't start any of our amounts until 250. So it might be a situation where we put a little squiggly mark here, and that means we're skipping from 0 to whatever that number is, so we might skip up and start at 200 and then go by our 50s or our hundreds. But making the point once again that choosing our scale here along the y-axis for our frequencies is an important part of the graphing process, because we want to make sure it gives a good picture of what goes on with that. Our next graph then is a time series graph. Here's our time series graph for the sales at Robert's Toy Company in 2002, and thousands of dollars. That's an important aspect to consider as we move forward. And then we have our 12 months here. So I'm going to slide down a little bit and see how much room we can't make here to sketch this. So basically that information is going to disappear for just a minute while I put our months down here along the x-axis. And I'm going to mark that as, I think it's 2002 is the year. Yep. So this is 2002. I'm also going to take a look here at our sales. Our sales go from a low of, looks like 12,000 up to a high of 57,000. So I think what we'll do here is we'll go by $5,000. So we'll go 5, 10, 15, 20, 25. So there's our sales in thousands of dollars. And as we've mentioned, the time series graph is a line plot. So in January we had 17, in February we had 18, in March we had 20, in April we went up to 28, in May we went all the way back down to 15, in June we went back up to 21, July we went to 19, August all the way down to 14, September lower yet at 12, October shooting back up to 22, November up to 32, and December all the way up to 57. And we connect those with a line. And there's our time series graph. As we move on, our next graph is a pie chart or a pie graph. And we have some legwork to do here, so I'm going to put a couple of other columns up here, percent and degrees. And we need to get our percentages. We need a total that we have here, so I'm going to add all those together so that we have a total. And that will be the number that we're going to divide by to get our percentages for each category. And if we add all these together, we get 1,909. So to find the percent of each category, I take 278 divided by 1909, 324 divided by 1909, and so on. And just to make life simple, I'm going to round those to the nearest percent. And I get about 15% here. 324 divided by 1909 is about 17%. 478 divided by 1909 is about 25%. 515 divided by 1909 is about 27%, which means 314 is about 16%. Now we could have a rounding error here, but I hope we all agree that our percent should add up to be pretty much at 100. From here, to get our degrees, I'm going to multiply each of my percentages by 360 degrees so I can have an angle to put into our circle down here. So I have about 54 degrees here, 15% of 360. 17% of 360 is about 61 degrees. 25% of 360 is 90 degrees. 27% of 360 is about 97 degrees. And 16% of 360 is about 58 degrees. And just like we did with the other one, this should add up to be about 100. This should add up to be 360. You know, if we're at 358, 359, 361, we might have a rounding error, but you get the general idea. So we come down here. Unfortunately, I don't have a protractor that I can put in here. So I'm going to try and find the middle of the circle and try and come straight out as much as possible. And I'm just going to sketch in each of these angles. I'm going to estimate. So 90 degrees would go straight up. 90 degrees is our widgets, and our widgets have 25%. Okay, so we want to label our category and our percentages on here. From here, I'm going to go with a 97-degree angle, so I'm going to try and come down and estimate 97 degrees to go out this way just a little bit. And our 97-degree category was the things at 27%. And as I said, I'm just estimating here because I don't have a protractor. I would expect you to use a protractor. So we're going to go with a 61-degree angle to be the Gidgets at 17%. We have a 58 and a 54-degree angle left. So we'll go 58 degrees here. That was what? 58 degrees was the what's at 16%. And our last one was something at 15%. I can't remember what it was. It was the gadgets at 15%. Okay, so again, without using a protractor, that's our stem or our pie graph. Puts our categories and our percentages on there. And again, I would expect us to be able to use a protractor to measure those angles. It'll look a little bit neater than this one, but hopefully from that you get the general idea. Our last graph, not really a graph so to speak, just an arrangement of numbers in a stem and leaf plot. So notice I have these numbers. We have 4, 8, 11, 14, 17. We have 20 numbers there. We're going to break those into different categories or different classes based on characteristics of the numbers. So our stem and leaf plot is a T-chart. So to make these different groups of numbers, I'm going to have to use the first 2 digits as my stem. So I have 210s, 220s, 230s, and 240s. And then the other part of this, the last digit goes over here, but they should also be in order from smallest to largest. So I have a 212, 213, a 215, and it looks like a 218 would be my last one. In the 220s, I'm just going to circle the 220s. 1, 2, 3, 4, 5. So I have a 221, a 223, a 225, 26, and a 28. I'm going to go to the 230s. I have 1, 2, 3, 4, 5, 6 of those. Looks like 232 is the smallest one. A couple of 236s, a 237, a 38, and a 39. And then I have the 240s, 1, 2, 3, 4, 5 of those, 242, 245, 46, 47, and 48. So that gets 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We have all 20 numbers listed in there, broken into different categories based on the first 2 digits being the stem, and our last digit being the leaf, and our numbers are in order from smallest to largest. There's our characteristic of a stem and leaf plot.